Assalamualaikum warahmatullahi wabarakatuh. Okay, now we are in our second last chapter for this course. Okay, so this chapter is about phase diagram. So phase diagram is actually, if you look up any textbooks, okay, that related to the metallurgical books, okay, so the phase diagram is actually is the major has the major components lah. But in our course, okay, we make it short, okay, or in other words, we just take one small portions in the phase diagram, okay, for you to have a better understanding lah. Okay, the phase diagram inside metallurgical technologies. Okay, so before we proceed, okay, regarding the phase diagram, so you must know the main point or the main focus, okay, inside the phase diagram, which is the solubility. Okay, solubility or the solubility limit. Okay, by definition, the solubility limit is the maximum concentration, okay, of solute, okay, that needs to be dissolved in solvent. Okay, for example, okay, you have water and sugar. So water and sugar will be soluble each other. Okay, so the solid will be the sugar, and then the solvent will be the water. Okay, so this is the simplest analogy lah for soluble solutions. But in terms of metallurgy, okay, because if you look at both as examples, okay, the solvent is a liquid, okay, so it is a liquid, such as you all know lah, okay, inside the lab you have a variety of solvents such as water, ethanol, methanol, etc. Okay, but in metallurgy, the solvent is not necessary to be a liquid. Okay, a solvent, okay, might be copper, and your solute, for example, might be iron. Okay, so kita nak tengok the solubility of this copper and iron towards each other. Or we can have apa lagi, aluminium, yeah, and we can have here apa lagi, macam-macam lagi lah, okay, magnesium and etc. lah. Okay, so kita nak tengok the solubility limit of these particular metals. Okay, so to understand more about solubility limit, okay, we take the simplest analogy or simplest example, which is sugar water system. Okay, I bet all of you has experience to make a air gula, betul tak? Okay, so semua orang mesti ada experience buat air gula, where you have your water or your tap water, and then you just pour your sugars, okay, and then it will be dissolved. Okay, so semua orang pernah buat air kan? Okay, so kita buat eksperimen lah sikit. Okay, so the y-axis is the temperature, while your x-axis is your sugar or sugar composition lah. Okay, so this is a composition. Okay, so when you put sugar here, so it means that here you have 0 composition of sugar, while here you will have 100 Okay, percent of sugar. Okay, and this is your temperature. The y-axis is your temperature, and your x-axis is your composition. Okay, based on this label, this is a composition of sugar. But remember, sugar water system, they have sugar and water. Okay, so it means that you have to include the water in the graph as well. So the water will be, kalau you look at the graph ni, the water will be inverse the sugar. Cuma kita silencekan saja. Okay, it is understood. Okay, it means that at 0% of sugar composition, it will be 100% of water composition. While at 100% of sugar composition will be 0% of 100% of sugar composition will be 0% of water. Okay, so maksudnya dia terbalik lah. Okay, kalau dia label sugar, so it means that the other way around must be the other samples. Faham tak? Sebab sini kan sugar and water, and kat sini dia label composition of sugar. So it means that the maximum number here will be the sugar. So the water will be contradict, okay, ataupun vice versa, okay, towards the sugar, maksudnya ke sana lah. Okay, alright, and then you have your graph. Okay, so your graph will sort of look like this. Okay, ini contoh lah, and this is, okay, kita taruh sini 60%. Okay, 60% of what? 60% of sugar, sebab dia dah label sini sugar. Okay, so you have 60% of sugar. Okay, and this is your solubility limit. Okay, this is your solubility limit. Maksudnya dekat situlah limit your sugar will be soluble. Okay, so at this point, your sugar will be soluble inside the water. Okay. Okay, so for example here, you have 60% of sugar at 0 degree. For example, yang ini kita start with 0, ataupun 0 tu macam tak promising kan. For example, sini kita start room temperature lah, 26 or 27. Okay, so yang ni dia keep increasing lah. Okay, so it means that at room temperature, you can dissolve 60% of sugar, okay, inside 40% of water. And for example, ni gelas you, ini sugar. Okay, and then you pour water 40%. You ada sugar 60%. Ni water. So later bila you dah kacau ke apa ke, so you will have a solution of air gula. Ni semua air gula. Okay, this is the air gula ataupun sirap lah. Okay, at 60%. Okay, what if you increase your composition of sugar? For example, this is your composition of sugar yang baru. For example, sini apa? 70%. So it means here you have 70% of sugar with 30% of water. Kan? So bila you tambah this 70% of sugar with 30% of water at room temperature, do you get your syrup? Kan? Yang ada air gula yang tak ada langsung dah gula, maknanya fully dissolved. Will you get that? Okay, so based on this solubility limit, okay, you tak dapat. Okay, so you boleh buat eksperimen ni juga kat rumah actually. Okay, kan, you ada sugar, ada water, you tambah banyak-banyak sugar inside the water. Okay, so lama kelamaan this air gula or the syrup will be saturated, so you cannot, maksudnya the sugar tu cannot no longer can be dissolved inside the water tu, dah tak boleh. So you akan dapat deposit of sugar at the bottom. Okay, so dah tak ada dah air, dia tak, maksudnya you cannot have the homogeneous solution. Okay, faham ah? Okay, at 70%, maksudnya bila you tambah, dia akan jadi deposition lah. Okay, but what if, okay, you have here sort of, kita boleh kata 50% apa, 50%. Kalau you letak 50% of sugar with 50% of water at room temperature, what will you get? Kan, you akan dapat tak air gula? Yes, you will get the syrup or the homogeneous syrup, because this is the solubility limit. Ini limit air gula tu nak soluble dalam air. So this is it. Okay, so from here you boleh tahu ada two phases here. So the phase, okay, on the left side of the solubility limit will be liquid phase, while the phase on the right side of the graph will be liquid plus solid phases. Okay, dia bukan solid phases but both phases. Kan? Faham ah? So towards on your left will be liquid phase. Towards on your right, you will have two phases, liquid and solid. Tak percaya, you boleh try kat rumah. Okay, so maksudnya bila you tambah lebih lagi, so you won't get a homogeneous air gula. Okay, but kan, you still need this 70% of gula with 30% of sugar. Kan, you still need this composition. Maksudnya you nak buat air gula yang paling manis lah, ataupun yang manis ini yang you nak. Okay, so what must you do? Sebab you tahu at room temperature you won't get this homogeneous system. So based on the graph, okay, kalau you nak juga 70%, okay, so you have to increase, okay, your temperature. Kan, for example here 80 degrees C. Kan, bila you increase your temperature, okay, sampai kat sini, so you nampak dia lebih daripada solubility limit graph. So it means that you can have your 70% sugar in 30% of water. Okay, so maksudnya the solubility, okay, solubility, okay, has the effect of the composition as well as the temperature. So dia ada effect dua ni. In the phase diagram also there will be two things, okay, that needs to point out, which is the phases, okay, and components. So what is phases? I bet every one of you know what is phases. Okay, so you have learned this since kindergarten. Okay, so phases, okay, as everyone knows lah. Okay, we have three phases, okay, in this world lah. Okay, the first one will be the gas phase, then liquid phase, next one will be the solid phase. Okay, so for the phase diagram, okay, we will take out the gas phase lah. Okay, so we mainly will look at the liquid and solid phase. Okay, back to the part 1. Okay, video part 1. Okay, you can also have another phase, which is liquid and solid phase. Okay, so you ada liquid phase or liquid and solid phase and pure solid. Okay, so these are the phases, okay, that commonly observed in the phase diagram. Okay, and then the other major things inside the phase diagram is the components. So components ni apa? So components ni, kalau contoh from your video 1 is actually your water and the sugar. Okay, so basically the components is the compounds ataupun the metals. Okay, so these are the components. Okay, components for the solubility lah. Okay, so based on this, okay, the phases and the components. Okay, so we have variety of phase diagram. Okay, there are a few phase diagram lah in metallurgy. Okay, which is we term it as unary diagram. Okay, so all type of phase diagram will be based on the number of components. Okay, for example, unary diagram, where you have one component only. Okay, for example, kalau sugar je lah. Okay. Second one is the binary diagram. So binary diagram, with the term bi depan ni, so it means that you will have two components. For example, your water sugar system is a binary diagram. Okay, and then you can have the ternary diagram. Ternary diagram where you have three components and etc. lah, and banyak lagi lah, 4, 5, and etc. So for your part, we will only focus on the binary diagram or with a two component system. Okay, so yang paling basic lah. Okay, so this is the major things inside the phase diagram. Okay, where you have the components and you have the phases. Okay, so as I mentioned before, when we talk about metallurgy ataupun kita cakap pasal ni lah, metal and alloy, so the components must be metals, betul tak? Okay, sometimes carbon pun boleh lah. Okay, so the components usually will be metals, for example copper, iron, aluminium. Okay, apa lagi? Kita boleh juga ada carbon, platinum, and etc. Okay, so these, kalau kita tengok sini, these are all solid. Okay, but as I mentioned before, this solid must have the solubility limit ataupun must be soluble to each other. Okay, 2 is the key point of the phase diagram, the solubility. Okay, so by right lah, kan, how do you soluble a solid? Betul tak? Kan, for example, you have pasir and apa lagi? Batu. Okay, pasir and batu both are solids. Can they both be soluble? Boleh ke? Kan, you have pasir and then you have batu. Okay, bila you letak dalam satu jar, pasir, batu. Okay, will they be soluble to each other? Okay, how can you say pasir and batu soluble to each other? Kan, kalau you tengok sini, you memang ada distinctly heterogeneous system where you can, and of course you can nampak the batu, and then you can nampak the pasir inside a beaker or inside a Tupperware and etc. lah. Okay, so how ataupun what is the criteria, okay, for you to highlight ataupun to pick up the metals, okay, for two component system ataupun binary system, kan? Sebab kita nak tengok binary, okay, so binary means they have two components. So macam mana you nak make sure that you have the correct solid, okay, that can be soluble to each other. Okay, so ingat ni adalah solid soluble. Okay, bukan solid and liquid macam air gula ni, is easy lah. Liquid and liquid pun senang, you nak soluble. Tapi ada juga liquid that cannot be soluble to each other, which is your water and your minyak. Tak boleh soluble juga. Okay, so you have to have some criteria, okay, to have a solid solubility for two components. So what are the criteria? So the criteria will be 1, okay, these solid, both lah, kan, solid A and solid B must have same crystal system. Okay, crystal system yang sama. Okay, so for example, if solid A has BCC crystal system, solid B might as well has BCC crystal system. Okay, and then the second point, okay, will be they have the same electronegative value. Okay, bukan the same lah, similar. You takkanlah boleh dapat the same sebab setiap komponen berbeza. So katakan A, you dapat the electronegative value is 0.1, okay, B lebih kurang 0.12. Okay, so you have a similar electronegative value. And then the third one, okay, they have the similar radius. Okay, for example, radius A, dia ada 0.03, for example, and B, you have 0.035. So they have the same radius number. So when you have all these things, semuanya complement, semuanya yang in the range, so you will have high, okay, mutual solubility ataupun high mutual solid solubility. Maksudnya those solid can be soluble to each other. Okay, nak senang faham, okay, you ambil satu bekas, you masukkan garam you and gula. Okay, kalau you masuk, of course lah, garam and gula yang you masukkan ni, this garam, okay, mestilah kalau you masukkan garam halus, gula pun you masuk gula halus lah, janganlah gula you masuk gula perang ke, gula besar, gula kasar, kan, gula halus. Okay, so you will get, okay, yang you nampak will be homogeneous garam dan gula, solid garam dan gula. You tak boleh nak pisahkan pun the garam and gula. Of course under microscope you can see lah. Okay, tapi secara kasarnya you cannot pisahkan pun ataupun you cannot distinguish the garam and gula. So this is an example of soluble solid. Okay, next, so we will look at how the phase diagram is constructed. how you read, okay, the phase diagram. So as I mentioned before, okay, we will only focus on the binary phase diagram. Oops. Okay, binary phase diagram. So it means that the phase diagram will have two components. Okay, binary phase diagram. So we take an example of copper nickel systems. Okay, where you have two components, copper and nickel. So first you need to know what is the melting point of copper. So the melting point of copper, okay, is at 1085 degrees C, while nickel melting point, okay, is 1453 degrees C. Okay, and then the crystal systems, okay, for the copper and nickels will be the same, okay, and all the criterias, okay, for the solid solubility are the same. So it means that this copper and nickel, okay, we can form a solid solubility in phase lah. Okay, so macam water and sugar diagram pun sama lah. So first at the y-axis, okay, we can have the temperature, okay, and at the x-axis we can have the composition. Okay, so macam juga I mentioned before in the water sugar systems, so the composition, okay, kalau they label as, for example here the label as nickel, okay, the label as nickel, so this x-axis, okay, at this point it must be 0% of nickel. At this end you have 100% of nickel. Okay, okay, so here 100% of nickel. Okay, well at this point is 0% of nickel. But remember, this is a binary diagram. Okay, or you have two different metals. Okay, so where is the composition of copper? So the copper must be inverse with the nickel. Okay, tapi kita silentkan yang ini. So it is mutual understood lah. Okay, so at 0% of nickel you can have 100% of copper. At 100% of nickel you can have 0% of copper. Okay, so it means that at this axis, temperature at this axis is purely copper. Okay, while y-axis at this end, okay, ini pun temperature juga, will be purely based on the 100% of nickel. Okay, so kita tahu the melting point of the copper is 1085. So it means that somewhere here lah. So katakan sini will be the melting point of copper. Kenapa copper here? Because this axis has 100% of copper. The pure copper will be here. Okay, while at the other end of the axis, okay, axis yang y-axis yang on your right, okay, will have the melting point of nickel. Okay, nampak eh? So here will be the melting point of nickel. Why? Because we have 100% of nickel at this point. Okay. Okay, so kalau you predict, okay, based on the predictions, okay, so sebab you ada copper nickel system, so ada dua sistem, so you perlu tahu juga dekat mana melting point of copper and nickel, kan, sebab dia bukan pure copper or pure nickel solely, but you have copper plus nickel. So can you predict, okay, where is the point, okay, where is the melting point of copper nickel alloys? So basically kita buatlah macam ni, okay, and then kita mesti take lah 50% of each other lah, so kita, to be fair lah kan, 50% each. Saya ingat lah. Okay, so you have at this point, okay, so this point is your predictions of melting point of this alloy. Maksudnya sini adalah you predict lah, this is the temperature, okay, for these copper nickel alloys to be melted. Okay, so adakah betul? So then macam biasalah, as a scientist, so mestilah kita ada predictions, and then kita mesti ada experimental, ataupun kita predict, tapi kita kena make sure jugalah our prediction tu is correct or not, okay, macam mana kita nak tahu, so kita kena buatlah eksperimen. And then when we did an experiment, okay, bila kita buat eksperimen, so apa yang kita nampak actually, okay, dia akan dapat this graph macam ni. Okay, so kenapa dia jadi macam ni? Okay, why you have this type of graph is actually bila you heat up your 50% of nickel and copper, when you heat it up, okay, you get this point, okay, below the predictions, okay, of alloys ni, of melting point of the alloys ni, you get below punya temperature lah. Okay, so what happens here is actually this is your what we call is the melting temperature. Okay, kita cakap sini, this is ataupun kita dia term as TS. Okay, this is where your alloys start to melt. Okay, tapi the melting process will ada certain range up to here, barulah the alloys are completely melt. Maksudnya ada range. Okay, katakan sini dia punya value, katakan A, the TL is B. So between A and B, okay, is the melting point of your alloys. Okay, so this is in difference with a pure metal. Kan, kalau you ada pure metal, katakan you ada copper, pure copper, so your copper ni when you heat up until 10885 degrees C, okay, so this is the beaker for example, and this is your copper. When you heat up until here, your samples, okay, your copper ni starting to melt. Tapi kalau you perasan, dia baru start to melt. Okay, ada lagi yang belum melt. Betul tak? Ada yang dah melt, ada yang tak melt. So, sampai habis semua ni melt, okay, so the temperature will remain constant. Okay, faham tak? Okay, in differs with alloys. Alloys ni starting dia dah starting to melt, sampailah dia completely melt. Okay, dia ada range of temperature. Kalau for pure metal, okay, the temperature tu remain until all of your solid is melted. Okay, another example, sama juga for the boiling point. Okay, so boiling point ni maybe senang sikit nak nampak because I bet you have did, okay, kita panggil macam purification of methanol ke ethanol ke in the lab. Maksudnya you collect, okay, ethanol ke atau methanol ke from a solution. Okay, you have the solution, okay, and then you have the condenser kan kat sini, and then you collect your sample kat sini. Okay, and you pernah buat tak? I rasa dalam organic class ada kot. Okay, so this is your sample lah kat sini. So, and then at some point, at some temperature, sini letak temperature kan, at some temperature, okay, katakan dia punya boiling point is at 80 degree, so dia tak akan increase, dia akan keluar your samples yang boiling point dia 80 degree kat sini, and then you starting to collect your samples A ni, tapi the temperature will remain at 80 degree. Kalau you perasan lah kan, bila dah habis all the A is being collected, then baru the temperature rise up. So same as this pure metal punya concept. Okay, sampai habis semua dissolve, then baru the temperature will rising up. But for an alloys, dia tak habis pun lagi dia tak habis pun lagi di melting process, the temperature tu keep rising. Okay, yeah. So from there, okay, you know that this point is the starting to melt point. Okay, so at this point your alloys will start to melt. Okay, while at this point, okay, the TL point, your alloys is having 100% of liquid ataupun will be totally melt. Okay, so from there you tahulah, okay, nampak at this point your alloy will start to melt, at the TS point will start to melt. Okay, and then the temperature will keep on rising up until the TL point. So the TL point is where your sample is totally melt, 100% in liquid. Okay. So from there, okay, daripada sini ni you tahulah, okay, sebab bila dekat TS dia baru start to melt, so it means that at this region, okay, you will have the liquid and solid phase. Okay, you will have these two phases, liquid and solid phase. Okay. Below the TS region, you will have the solid phase. Okay, so dekat sini solid. Okay, so solid ni bukanlah single, heterogeneous solid ataupun satu solid saja, but the solid will compose of copper and nickel. They're both soluble to each other lah. Okay, so below the TS punya line will be the solid phase. Okay, and then above the TS point will be the liquid phase. Liquid of what? Liquid of solid and liquid of apa ni, copper and nickel. Okay, so tak nampak dah liquid ni. Okay, so this is the liquid phase, liquid and solid phase, solid phase. Okay. Okay, so kita dah tahulah. So bila kita cakap pasal solid phase, so usually they term it as solid, they tulis solid ataupun they write it as alpha phase. Okay, nampak tak? They write it as alpha. So alpha means solid ataupun soluble solid. Okay, maksudnya homogeneous solid. Okay, kalau for the liquid kita term as L saja. Okay, so why at this point we term it as TS? Kenapa bukan TL ataupun TM? TM is the melting kan? Kenapa bukan melting? Sebab ingat melting, biasanya melting usually kita refer to a pure metals ataupun yang the pure components lah, okay, not to an alloys. Okay, so, tapi kenapa kita term it as TM? Okay, so why? So this TM is TM lah, TS. So this TS is actually come from the word solidus, which is solid. Kan, sebab dia daripada solid, okay, and at this point dia dah starting jadi solid plus liquid. So this is the limit for solid phase ataupun ini limit homogeneous solid. Above this line, okay, you cannot have solid anymore. Maksudnya you ada heterogeneous system which is liquid and solid. Okay, so this line kita panggil solidus line. Okay, line yang atas ni, okay, line yang atas, okay, kita ada TL and above this will be liquid. So TL, okay, referring to liquid lah, kan? TL is liquid, and this line, okay, we term it as liquidus line. Okay, so basically this line is the limit for the alloys to become liquid. Maksudnya above this line the alloy will start to have a homogeneous liquid. Okay, below this, ini above lah, above this line, okay, your alloys will have homogeneous liquid. Below this line your alloys will have homogeneous solid ataupun alpha. Between this liquidus and solidus line, you will have a composition of liquid and solid phases. When you look at the phase diagram here, you can actually determine the phase presence. Okay, so for example, you have 60% of nickel. So kalau you look at the x-axis, so this is the composition of nickel. So maksudnya kalau 60% will be here. Let's say this is the composition of copper. So where is your 60%? Okay, ini example lah. Example ini adalah percentage of copper, bukan nickel. So, kalau dia cakap 60% of nickel, it means that your nickel must be somewhere here lah. Okay. Okay. Sebab dia inverse kan? Okay, so in this case 60% of nickel. Okay, sebab memang ada bubuh nickel, so will be here. Okay, at 1.1 K degree C. So it's about here. Kan? So sini. So how many phases that can you observe? So you can observe alpha phase of one phase only. So alpha means solid phase. Kat sini bawah solidus line will be solid phase. So that's why you can observe one phase, which is the alpha phase ataupun the solid phase. Okay, what if you have 35% of nickel? So it will be somewhere here, 35% of nickel. At which temperature? At this temperature. So temperature sini. So how many phases can you observe here? So this is in between the liquidus and solidus line. So it means that you will see two phases, which is a liquid phase and as well as the solid phase or the alpha. Okay. From the phase diagram, you can also determine the composition of each phase. Maksudnya composition setiap phase itulah. Okay, for example, okay, at 35% of nickel. Tengok kat sini, the y-axis is nickel, so 35%, okay, is here. Okay, kat sini. And then at this point, okay, so you ada bila you buat lah one line sampai to the top, so you ada different phases, kan? Such as kalau kat A, okay, at this temperature 1320 A, you will observe liquid phases only. So you will have one phase which is purely liquid, which is 100% liquid. Okay, so that is the composition of the phase, 100% liquid phase. Okay, kalau you turun lagi temperature, you ada TV temperature, which is at 1250 degree C. Okay, so kat sini you boleh observe both alpha and liquid, alpha and L composition. Okay, so dia ada dua. So how do you determine the percentage of each composition too? So nanti kita akan tengok on the next slide. Okay, tapi when you go further down, okay, sampai this D symbols ni, okay, as at 1190 degree C, okay, kat sini. So you can only observe one phase, which is the solid phase. So this at this point at 35% nickel, you can have purely solid or 100% solid. So tu senang, okay. Yang ini pun senang, 100% of liquid. So tak payah fikir. But at here you have two composition, liquid and solid. So how do you determine the composition of liquid and solid kat situ? Kan? Sebab maybe liquid dia banyak ataupun alpha dia banyak ke, ataupun alpha dia banyak, liquid dia kurang ke. So you need to determine that. Okay, while this one memang 100% lah, memang 100% liquid, while at this point memang 100% solid. So how do you determine at this point berapa banyak ada liquid, berapa banyak ada solid? Okay, we will look that on the next slide. Okay, so to know the percentage of liquid and alpha at this point yang B ni, okay, so kita tengok dia punya weight fraction. Okay, so instead of percentage, kita tengok the weight fraction. Dia sama je lah. Okay, so for example, A ni 100% of liquid. So the weight fraction must be 1 lah. 1. 1 tu maksudnya 100% lah. 1. Okay, so you have weight of L, liquid, 1. Weight of alpha, which is a solid, will be 0. Sebab sini 100% of liquid. Okay, while at this point, dan TD ni, kan, dia 100% of solid ataupun alpha. So it means that the weight fraction, the WL, will be 0. You tak ada nampak pun liquid there, while the W alpha ataupun yang solid will be 1 kan. Okay, so maksudnya 1 tu means yang purely 100%. Okay, what about B? So you ada two types of things here, L and alpha. So how, okay, do you determine at this point berapa banyak weight fraction of L and alpha? Okay, first you need to draw a tie line. Ini tie line. Okay, so kita tahu dia dekat sini dia consist of liquid and alpha. So you must draw a tie line, okay, yang menghubungkan liquidus and solidus. Okay, sebab apa? Sebab at this region dia ada liquid and solid. So you must create a tie line. Tie line tu mesti straight lah, janganlah buat sengit. Okay, straight, okay, melalui the B point, temperature B. Okay, maksudnya temperature ni semua sama lah. Temperature kat sini, temperature kat sini, temperature kat sini semua sama, which is the TB. Okay, so you buat the tie line ni mestilah, okay, one point atas liquidus line, another point will be atas solidus line. Why? Because this is liquid and alpha region. Kalau let's say di sini adalah alpha and beta region, so this point mestilah satu point dekat alpha, satu point dekat beta, to example. Okay, but here this region is liquid and alpha region, so you must draw your tie line ni, okay, satu menghubungkan liquidus line, then another one menghubungkan solidus line. Okay, so from this tie line, okay, so you akan nampak you ada two side. Okay, toward this side, okay, kita term it as R, ataupun towards this side kita boleh lihat weight of L. Okay, toward this side is the weight of alpha. Okay, the S. Okay, so R and S ni senang, RS lah, lepas R baru S, bukannya S and R. Okay, so R and S, okay, kita write is as R and S. So how do you determine, okay, the weight fraction? Okay, satu, untuk nak cari the weight of L. Okay, the weight of L, sini L kan. So the weight of L kan, starting from the liquidus line ni, kalau banyak L at this point, okay, so you kena ambil nombor yang ataupun value yang bertentangan, which is the S. So S over R plus S, jarak between this. Okay, sebab you nak cari WL here, and you want to find WL, so WL is actually S, okay, bahagi R and S with W alpha. So W alpha will be bertentangan, will be the R, okay, over R plus S. Jangan WL you ambil R. Okay, tak boleh, dia kena ambil yang bertentangan. Okay, simple lah. Okay, so WL will be S over R plus S. W alpha will be R plus S. Okay, and then you masukkanlah nilai tu. Okay, for example here, dekat this point, okay, is 43. At this point is 32. So R means jarak antara B with 32. So R means 35 minus 32, where you get 3. Okay, while S adalah jarak between here, okay, the solidus line and B, which is 43 minus 35. You will get 8. Okay, so you masukkan dalam nilai ni. Okay, so jarak antara R dan S, so total R plus S will be 11. So it means that W is either you write it like this, tapi takut you keliru, so better you use this equation. So S is 8, R plus S is 11, then you will get 0.03. R is 3 over 11, then you will get 0.2742 for weight fraction of alpha. So kalau you combine this together, you akan dapat 1. Okay, so maksudnya 100% lah, kan? Sama lah dengan ni ataupun ni. Untuk yang ni tu nak check lah whether you get the correct value or not. Okay, tapi W untuk you nak cari the fraction of L will be 0.73. The fraction of alpha will be 0.27. It means that at B point you get weight fraction of L equals to 0.73 and weight percent of alpha equals to 0.27. Sebab dia tak ada yang 100%, dia ada this both composition. Mentioned before, the phase diagram, you can observe the different phases. Okay, so where you have a liquid phase, solid phase, liquid and alpha phase, or liquid and solid phase. You can observe these phases in the phase diagram. So when you look at further down, at a microscopic level, as you tengok under microscope, you can actually define these phases clearly. For example, you have 35% of nickel. You have 35% of nickel here. So when you create one line there sampai atas, so you can find different phases at different temperature. For example, at A temperature, you can find purely liquid phases. Liquid phase. Nampak? Semuanya liquid. When you go down, at this line here, ni line ni kita panggil line apa? This is the liquidus line. It means that at this line, your liquid samples tu starting to have some solid. Ingat, sebab for an alloys you don't have a specific temperature for melting point, so you have a range temperature for melting point. So at the liquidus line, you can have some solid. Kalau you tengoklah under microscope, maksudnya at this point yang ada atas liquidus line, so you akan nampak some solid inside the liquid. Maksudnya dia bukan purely liquid, tapi the solid of course is very little lah, ataupun smaller. When you go down lagi at the point of the L and alpha region, at C ni and dekat alpha and liquid region, you can find bigger solid. You akan nampak lebih banyak solid, ataupun solid tu lagi besar. At the solidus line here, kalau you observe dekat D, at temperature here, dekat solidus line, you can observe more solid, but smaller amount of liquid. Sebab apa? At this line, your alloys, will starting to melt, ataupun starting to become liquid, tapi bukan 100% liquid, tapi dia baru slowly become liquid. And then slowly become liquid, so the solid tu akan disappear. Lama jadi sikit sangat disappear, last sekali will disappear totally lah. That's why you get all green. Sama juga kalau turun bawah, dia akan jadi liquid, solid sikit, bigger solid, and then you can find bigger solid. Bila turun lagi bawah, bila dah masuk dalam solidus punya region ataupun solid region, So you won't find any liquid. So this is a totally solid. Okay, so ini will be your apa ni? Unit cell, your and etc. tu lah. Okay, so dia ada dia punya crystal system dia. Okay, so this is the purely solid. Okay, so this what you will observe under microscopic level. Okay, next kita tengok pula binary eutectic system. Okay, binary ni macam as I mentioned before, when you have two components, okay, such as copper and argentum system. Okay, so you have two components, so that's why we term it as binary. Okay, so the new terms here is the eutectic. Okay, so what is eutectic? Eutectic is actually by definition lah. So when you have liquid phase, okay, that will transform to two solid phase. So yang ni yang baru sikit lah, two solid phases. So actually kalau you go through your notes, okay, actually we have a few systems which is eutectic, eutectoid, okay, and peritectic. Okay, so you can find all the definitions dalam notes you. Okay, cuma kita akan fokus on eutectic sahaja, which is point at a point that your liquid will form two solid phases. Okay, so you look at your phase diagram kat sini. So this is copper argentum system. This is the temperature macam biasa, and x-axis you have percentage of argentum. Okay, so maksudnya this 100% will be argentum, bukan copper. So this is 100% of argentum. So it means that beta here, okay, kita tengok beta here. So ini alpha plus beta, maksudnya ini adalah binary systems. So kenapa dia alpha plus beta? Alpha we refer to here, the alpha. Beta we refer to here. So beta here, kalau tengok beta is kan at the line of 100% of argentum. So it means that this region is a solid region. Beta will be beta, okay, will have the meaning lah. Maksud beta ni is the argentum and alpha is the copper, because ini 100% of copper. So maksudnya you ada two solid phases here. Memanglah two solid phases ni is a homogeneous phase, tapi you ada two type of solid phases. Okay, so mana satu eutectic point, mana satu temperature, eutectic temperature is this point. Yang ni, yang nampak ni. Okay, this point ni. Why? Because at this point, okay, your liquid phase, okay, will transform to two solid phase. Ni alpha plus beta. So this is the eutectic point. Okay, if let's say dia cakap find the compositions ataupun find the fraction, okay, at eutectic point, so you must buat tie line between alpha and beta, okay, melalui eutectic point. Sebab apa? Sebab dia ada alpha, dia ada beta. Okay, sebab dia ada two phases. So pergi ke point sampai ke alpha sampai ke beta. Okay, yeah? So with this, okay, phase diagram also you can find at the green zone ni is your liquid phase, which is purely liquid, okay, 100% liquid of copper argentum. Well, at this point, okay, will be alpha plus beta or solid phase of copper and argentum. Okay, so kat sini semua solid, tapi solid siapa? Solid alpha and beta. Okay, sini is the eutectic point. Okay, so here is the region for liquid phase, tapi with alpha phase only, ataupun liquid with copper only kat sini. Okay, while at this point liquid with argentum. Okay, bukan liquid, maksudnya liquid with solid argentum, liquid with alpha argentum, argentum and copper solid, liquid copper and argentum. Okay, faham eh? So belah sini, okay, on your left side, okay, from the eutectic point will be liquid and copper ataupun liquid and alpha, belong to here lah. On towards your right side of the eutectic point will be liquid plus beta ataupun liquid and argentum. Sini purely argentum, purely copper. Okay, sini tak ada argentum langsung, sini tak ada copper langsung. Sini ada copper and argentum. Okay, sini solid, sini solid. Okay, merah solid, biru solid, cuma this solid is purely copper, this solid is purely argentum. This will be mix of copper and argentum solid. This will be mix of copper argentum liquid. This region, okay, will be liquid plus copper solid. This region will be liquid plus beta solid. Okay. Okay, so it means that below the eutectic point, TE is the eutectic point. Below eutectic point will be solid, no liquid. Okay, above the eutectic point will be liquid. Okay, sebab eutectic point is a point where liquid will transform into two solid, which is alpha and beta. Okay, so from this phase diagram, okay, you can observe three single phase, which is the liquid, alpha and beta. Okay, lepas tu adalah liquid plus alpha, liquid plus beta, alpha and beta. Okay, okay. Kalau disuruh cari di apa ni, weight, okay, fraction at eutectic point. So maksudnya you kena tengok which one is the eutectic point, which is this point, and then you have to create a tie line. Okay, tie line ni kenalah at eutectic point, which is at this point, and then you buat straight line. Okay, yang satu menghubungkan alpha, satu lagi menghubungkan beta. Sebab apa? Sebab dia eutectic is liquid to alpha plus beta. So satu kena menghubungkan alpha, satu kena menghubungkan beta. So this is your eutectic line. Okay, so eutectic line, but this is the tie line. So macam biasa, kalau you nak cari the weight percent of alpha, so kat sini you kena label. This one is, tu warna merah lah. This one is R, this one is S. Okay, ni region R, ni R, ni S. So W alpha will be, kan, yang sebelah sana punya value S over R plus S. W beta will be beta, kan, beta. So dia punya sebelah sana will be R over R plus S. So this is the weight fraction, okay, value X, and this one value Y. So this is the weight fraction of alpha. This is the weight fraction of beta at eutectic point.